Hi, it's me, Franklin, and welcome back to Comp 2160. I am at home and I'm feeling kind of sick, so I don't have my camera turned on, and I hope that you don't mind. As promised, I want to try and take some time to go through my sample solution for assignment 3, and just to give you an idea of how I approach this problem. So, first things first, the thing that I spent a lot of time doing for this implementation was to design my data structure first and foremost. I had two parts to my data structure. I had the zone itself, and when I did this, I kind of went through and I tried to write these comments that you see on the right side of the screen for each of the properties that I was using. Basically, try to make sure that I'm putting my assumptions about the state of these different properties immediately in these data structures before I get going with everything. My implementation of a zone, I have the data that the zone is managing. This is an unsigned character pointer. Uh, Internally, I want my zone to be managing bytes, and the unsigned char data type lets me represent things as a single byte. So each unsigned char is always going to be guaranteed to be a single byte. I have this active property, and this is really only a way for me to try and make sure that when I've got these zones, if I destroy it, I can try to do some best effort to say, like, this is not a valid zone anymore, so you shouldn't try to pass it to my zones. But I don't ever really use or test this in any way. I keep track of the number of free bytes that are in my zone as a separate property. This isn't necessary, but I decided to do this to try and add a little bit more to the invariant that I have for my zone. One of my invariants that we'll see in a little bit is that I want to count how many bytes are free and confirm that as I'm going through the list, I can count up how many bytes have been allocated with the zone size, and then use the difference of the zone size and the free bytes to determine whether or not I have the right number of free bytes. My blocks property here is the list of the linked list of allocations that have been made, and then the number of blocks is just the number of blocks. Again, I'm keeping track of this because I want to have some additional information to make sure that in my invariant I have a valid zone structure. The blocks themselves also have an unsigned character pointer, but these unsigned character pointers don't point to like different data. They're pointing to regions inside of this in the zone structure itself. The block size is the number of bytes that were allocated in this allocation, and then I also have a kind of a back pointer to the zone itself. I'm using this as part of my invariant. This is a linked list, so I've got a link to the next node, and then I also keep track of which element in sequence this block is. So if this is the head of the list, it's going to have index 0. If it's heads next, it's going to have index 1. If it's the tail of the list, it's going to have the number of blocks minus 1 as its index. This is my invariance for my data structures. So the block here, it's assumed that it's not null. If it's a block, it must be owned by someone. The block size must be greater than 0, and the block size is less than or equal to the zone size that it's contained within. So it cannot be bigger than the zone size, and it must point at something. Similarly, the index here, it's got to be greater than 0, and it has to be less than the zone's number of blocks. So again, I'm keeping track of this just really to try to keep track of some additional information in my invariant here. And then the next pointer can only be null if this is the tail of the block. So keep track of whether or not this is the tail. So that's this first argument here, this first part of the assertion. It has to be the last thing in the list, or its next should not be null. For the zone, we have similar properties, so this is kind of similar to some of the other things we've done. It's not null. The thing that is pointing at must not be null, or the zone active is false. So this is one of those places where I'm using that active flag, but I'm not really using this too much. The number of free bytes must be greater than 0. And I commented here, this is an unnecessary check. This is enforced by the type. Free bytes here is that Z size T, so it's an unsigned sign. It's an unsigned integer, and that means that it can't be less than 0. The number of free bytes is got to be less than or equal to the zone's size. So we can't have more free bytes than we have space allocated in the zone. This one here, the zone size is greater than 0 or the zone active is false. This is another one of those places where I'm, best effort, I'm going to say that the zone is not a valid zone anymore, but it's possible for it to be in that case. If it is an active zone, so this is where it's true and this is where it's a valid zone, then the number of bytes in the zone size should be greater than 0. And then this one here is checking to make sure that the alignment, so this is the part where we're trying to make it divisible by 8. If it's divisible by 8, then that's a part of a valid zone. Otherwise, the zone active is false, so it's not a valid zone, and we're setting the zone size to be 0. The last two here are the blocks is not null, or the free bytes is equal to the zone size. So what this basically means is that we have a node in the list, or we have no nodes in the list and the free bytes is equal to the zone size. So that means we don't have anything in the list. We haven't done any allocations. The other one here is that the blocks is not equal to null and the number of bytes is number of blocks is greater than 0. So if number of blocks is greater than 0, then the blocks is not null. Otherwise, the number of blocks must be 0. Then here we're going through and we're counting the blocks in our list, and we're also counting how many allocated bytes are in the list. And then this is the last assertion here where we're checking to see that the number of free bytes is equal to the zone size minus the allocated bytes that we counted up as we went through all the nodes in the list. This function here called align, this is something that I have as a private function. This is not for use outside of this code, so I've marked it static here. And what I'm trying to do is trying to make it so that if the value that's passed in is not a multiple of 8, then I'm going to make it a multiple of 8. So this first option here is that it is already a multiple of 8, so I don't need to change it. And this expression here will turn it into a multiple of 8. So the alignment size less whatever is left plus the original. So just trying to push it up to the next thing. The make zone function kind of goes through and just initializes the zone structure. I'm allocating the zone itself with malloc. I'm changing the zone size to the proper alignment with that align function. I'm allocating the data after I've done the alignment. And then if I'm checking to see if the data was allocated, so malloc will return null if it can't allocate it. And only if it's able to allocate that data, then I'm going through and I'm basically initializing my zone to be an empty zone, so there's no allocations. And this is my final post condition here. The zone should be a valid zone. If I have not been able to allocate data, then I'm going to release the zone that I previously allocated and then set zone to null. I don't have to do this part on line 149, but I'm doing it anyway. The zone size function is pretty straightforward. I'm just checking to see that I have a valid zone as a precondition, and then I am using a conditional check to make sure that I'm not going to segfault, and then I'm passing the zone size back. So this is effectively the same as whatever was passed into the make zone function, although it's something that's going to be aligned to the next 8 bytes. I'm going to skip past this for now, and I'm going to go all the way down here. I'm going to keep going down to zalloc. So my zalloc function is pretty small because, as you saw in all the lines that I skipped there just a second ago, I've moved a lot of that functionality into separate functions. My zalloc function has some preconditions that are basically that we have a valid zone and that the block size that we're trying to allocate is greater than 0. And then I have conditional statements to make sure that I'm not going to get a segfault. Really specifically this part, the z not equal null. I'm trying to make sure that I'm not going to get a segfault. And then I'm doing things separately. The first part is I'm going to try to apply the first fit allocation policy. My first fit function returns a pointer either inside the zone's data, or it returns null. It returns null when you can't do, or there is no space inside this zone to satisfy the block size that's been requested. If it was able to find something for us, then I do an ordered insert. My list, I try to keep track of the order of insert of the pointers. I'm trying to make sure that each node's address is sequential. So the head has the smallest, is closest to the start, and the tail has the biggest, is closest to the end of the block of data that's been allocated for the zone. And then I do memset. This is that we're zeroing data. And then the last part here is that my post condition is I want to make sure that my zone, I want to make sure that my block is still valid. And then I'm actually going to add something here. I should be able to say check zone at the end of this thing. So I've made changes to my zone. It should still be a valid zone. I'm going to go up to my first fit function. And here's my first fit function. I've put some comments here because this is not something that's part of the interface. This is a private function, so it's static. I've set this function's return type to be void, but it could also be an unsigned char. And then what I do here is basically do some simple checks. Do I have enough space to make sure that, do I have enough space in the zone at all to be able to allocate this block? If I do have enough space, then I kind of need to go through and check, have I allocated anything before? If I haven't allocated anything before, then I have enough free space and I should just put this to be the head of the list. If I have allocated something before, but I need to put it before the start of the first allocation. So this is z blocks is not equal to null. There are elements in my list. Num blocks is not equal to 0. There are elements in my list. But the data that we have here plus the block size is less than the head of the list. So this is basically we're inserting before the head of the list. And in here, I'm not doing any insertions. This is just first fit. So I'm just trying to find the space where I want to put it. If neither of those two are satisfied, so I'm not going to be inserting to the front of the list, then I need to go through and find a space. So I've got a loop here that is a while loop that's checking to see if I've got something in between nodes that I can then add to. I'm going through the process of trying to find a space by iterating through. I'm checking between each of the nodes that I've got to see if I can fit in there. And then what I'm doing is I have two options here. I'm either in between two nodes, and that's the between part here, and here is where I'm trying to say this is where the block pointer should go. It's after the last one, after the previous one that I found. Otherwise, I'm trying to insert into the tail of the list, and this is just trying to make sure that I can put it at the tail of the list. I have added an assertion here that's basically saying I want to make sure that I am at the end of the list. So previous should not equal to null, and prev's next should be null, and cur is equal to null. In my last case, my post condition here for my private function is that I have either got a null block pointer or I've added something that's, I've found a block pointer that's within the range of the zone's data region. The ordered insert here then is now just an ordered insert into the list of nodes, and I'm going through and trying to find the two nodes that I'm supposed to insert in between. You may have done this all as one big thing, but I found it easier for myself to separate these two things out into different parts. The block size function is fairly straightforward. I'm going through the process of trying to find the node that has that block pointer and returning the block size. The z-free function, I didn't do the whole process of like first fit and then ordered insert because this is all just going to be modifying the list, and it's just going through the process of checking to see if I can find the block pointer in the list that of blocks that I've got, and if I can find it, then I'm going to delete it. So I'm going to remove it, and then the part where I'm deleting the node here is on line 483 where I'm freeing it, and then I'm deleting the node. The destroy zone function goes through removing all of the nodes in the list. You may have called your Z-free function repeatedly from here. That would also be okay. And the Z-dump function is going through and it's printing out information about the zone. Again, this whole active thing is kind of an extra thing that I didn't really mean to, that I didn't use too much, but it was more about in my Z-free function or Z-destroy zone function here. This is an attempt at invalidating the zone before freeing it. The free function doesn't delete the data that you have. So when I call free, it's not going through and it's not zeroing everything out here. So this is my attempt at zeroing everything out. In my client code, so if I take a look at my main zones.c code here, in this code, when I call make zone, after I call destroy zone on Z, I could still use this. I could do something like zalloc Z and 10. There's nothing stopping me from doing that. This pointer is still a pointer. It still contains the same address. The Z active part is me trying to say, don't pass this anymore, please. This is not a valid zone, and you shouldn't use it anymore. While we're here now, the tests that I've got are, I'm testing the alignment. So I'm basically going through up to 16. I mean, we could go even higher than this if we wanted, but I'm just trying to make sure that the size of the zone is always going to be some multiple of 8. The test alloc size function here is going through and it's allocating a single block within the zone and verifying that the block size is what we're expecting it to be. The test alloc too big is trying to prevent allocating things that are too big. Not trying to prevent it, but trying to verify that it's not too big. I'm not able to allocate something that's too big. This part is trying to allocate a couple things. So we're allocating 8 total bytes, and then we're trying to allocate 12 bytes when we have only 16 total bytes. The test alloc free function is going through and it's allocating repeatedly, but it's also trying to write data in there to make sure that my zones are not going to overwrite each other, basically. I want to make sure that they're not overlapping. This was kind of represented in one of the test cases that you had in the test suite that I gave to you. Test alloc without free. All I'm doing with this one is like I can't actually evaluate that destroying the zone has done anything. The presence of this function is here so that when I run this with Valgrind, it will report no leaks possible. That's what I'm trying to see from this allocation. This test alloc free sequence, what I'm trying to do here is do a bunch of allocations and then release those things basically all from the front. So I'm always trying to delete the head of the list in this function. And then the test alloc free reverse sequence is trying to do the opposite. I'm always trying to delete the tail of the list in this function. The test free space at head, I'm trying to force first fit to happen here. So I'm trying to force first fit to happen by making some big allocation, allocating a bunch of things inside of it, releasing the first 2 allocations, and then trying to put another one in that should fit within those first 64 bytes that I just freed. So I'm trying to make sure that I'm reallocating at the same thing by checking to see that I've been able to do that. The test alloc fill is making sure that I am able to allocate within the zone the full thing. I want to make sure that I can allocate 128 bytes within a single zone. And then that's it. That's the end of that function. So these tests, these implementations should go through and satisfy all the tests. I hope that was mostly coherent. Again, I'm sorry I'm a little bit sick, and I hope I am feeling better to see you on Thursday. So good luck on your final exam, and I'll see you later. Bye.